Hi, I'm Mykola Mirshinchenko and welcome to my channel. There are a lot of cross-platform frameworks out there, but which one is the right one for your project? To better understand the advantages and disadvantages of cross-platform frameworks, in this video I'll compare the three most popular ones: React Native, Flutter, and KMP. But first I want to ask you a question. Do you know how many cross-platform frameworks there are? Give it a guess. Well, I counted 9 actively maintained cross-platform frameworks as of now. That's a lot of frameworks, so why do we need another one? I'm glad you asked. On a high level, each one of these frameworks caters to different developers, and each one has a different use case. To better understand the three most popular ones, let's do a high-level comparison. The first and most obvious point is, of course, all of these frameworks have their own language. KMP has Kotlin, Flutter has Dart, and React Native uses JavaScript. This, of course, makes React Native more attractive to web developers and KMP to Android and Kotlin ones. Moving on to the release date. Kotlin multi-platform became stable fairly recently, only 2 years ago. The other frameworks are far older, with React Native being the oldest one and having been released around a decade ago. GitHub stars. This metric shows how popular the framework is and how much adoption it gets. The leader here is of course Flutter because of how mature it is. Even though it got released 2 years later than React Native, it saw more adoption among mobile devs because of the ease of use. Next up is UI rendering. We'll go into this in more details in the next slides, but the main thing here is that Flutter and KMP essentially have no UI rendering overhead compared to React Native. This is due to the Skia engine and the fact that you can use native UI in KMP. In terms of performance, KMP and Flutter are ahead of React Native. KMP compiles directly into platform binaries and the performance is equal to native. Flutter's apps might take a little more time than native, but are comparable in efficiency. And React Native is generally slower because all commands have to go through a JavaScript bridge. As for code sharing, Flutter and React Native both have full UI and business logic sharing out of the box. But KMP has an advantage here over other frameworks. With KMP, you can decide whether you want to share all code, only business logic, or only a part of the business logic. This is great for gradual adoption. You can do this in Flutter and React Native as well, but it requires significant effort and is not supported so well. And this brings us to our next point, integration with native code. This is where KMP truly shines, because as you will see further in the video, the integration of native code in KMP is effortless. This is also possible in other frameworks, but as I previously mentioned, it's far more complex and has certain limitations. Next up is the ecosystem and libraries. Flutter and React Native have matured over the years, and therefore have numerous libraries and significant community support. However, KMP is catching up fast. Recently, Google has announced that it will also work closely with KMP to port as many Android libraries as possible. And last but not least, adoption difficulty. This one's pretty easy. React Native is best for web devs, KMP is great for Kotlin and Android engineers, and only Flutter has a unique language and framework that needs to be learned from scratch for all developers. Now, to better understand how these frameworks work, let's see how they render UI and how they interact with native components. How do KMP, Flutter, and React Native work? Specifically, as mobile devs, we're interested in the way they access native APIs and how they build the UI. I'm going to preface this by saying that, of course, this is a simplified explanation of how they work. These are very complex and sophisticated frameworks, so their architecture can be really covered in 2 minutes, but I'll try. First up, we have React Native. React Native by default comes bundled with the Hermes engine, which is supposed to be more efficient than its predecessor, JavaScript Core. Now, to communicate with native components like sensors and other things, Hermes utilizes something called a bridge. This bridge then communicates using messages with native framework like Android or iOS to call the needed APIs. And that's how it works with native components. As for the UI, React Native builds JSX components, and those map directly to the native components under the hood. Next up, we have Flutter. Flutter cannot access native components directly either. For this purpose, Flutter utilizes something called channels. Similar to React Native, channels communicate with the platform like Android through messages. The channel sends a message with certain requests and receives an answer from a native component. On the UI side, Flutter used to have a Skia engine, but has now migrated to Impeller. Both of these are very efficient and fast engines that help Flutter render the UI quickly. And finally, we have Kotlin multi-platform. The beauty of KMP is that there is no middleman in communicating with native components. You simply use Kotlin to call native APIs. This means there is no overhead for communicating with sensors and other native code. For rendering, KMP has two options. The first one is Compose Multi-Platform, which uses a Skia engine to render the UI for all platforms. The second option is to use an actual native UI like SwiftUI, Compose for Android, AppKit, and others. In this case, there are no limitations whatsoever. You can build a pixel-perfect screen native to that operating system. In this video, we did a high-level overview of these frameworks. We also looked at how they work with native components and the UI. Hopefully, it gives you a better understanding of why they exist and where they outperform each other.